Welcome to another Great Cow BASIC tutorial. This is part 8 for the PIC18FxxQ41 chipset. Now, what we're going to do today is do some serial communications between the chip and the PC. What am I using? I'm using a microchip, a low pin count demo board. Hopefully going to get a nano very shortly. And what we're going to do, let's have a quick look at what that looks like. It looks like this. This is where we left it yesterday. The board is connected. I've got two wires connected additionally from yesterday, and I'll show you about those in a moment. The layout looks like this with these two extra connections. One is to the ground and one is to the TX. I am going to be quite clear about this. Okay, I am going to move those to C6 where they should be. There we go. Nothing wrong with that. Doing the presentation live. There we go. I'm going to. That's where they're connected to. The third pin on the left. I'll talk about its naming in a minute. So what we're going to be doing is sending some data from the PIC via something that's called the USART, which is the Universal Synchronous Asynchronous Receiver Transmitter, on the inside that PIC through a USB TTL converter onto the PC terminal. So I've added in a TTL USB serial converter because it takes the signal from the PIC and then turns it into something that the computer can understand. What do they look like? They look like this. I've connected in, as I said, I've connected in the ground, this pin here, the ground, and I've also connected in the receive. So my TX on my PIC is connected to the RX on here. You're quite safe to connect them. Just connect these two up. In actual fact, I should be using the term TX1 just to make it very clear. It's transmit because there's more than one USART channel in this PIC. So how do I make that happen? Because this is what's called a PPS chip. And the PPS chip has something that's very special about it. You can redirect the port. So PPS is the method that allows you to select where you connect logically or physically the USART. And I'm going to connect it into port C6, and I'm going to show you how to do that. This is there because you can actually put it wherever you want within your design, within certain constraints, but it's much easier than having one that's fixed. I could have put it anywhere within the constraints of this chip. So for serial and for many other outputs or inputs, you must use PPS. Quite complicated stuff, but we made it very easy in Great Cow BASIC, and I'll show you that very shortly. So what we're going to do is we're going to do exactly the same as yesterday, but we're going to send some values out to the, where's my pen gone? Oh, it's over there. We're going to send some values out to the serial here. That's all I've added in here. It's exactly the same. Oh, we've got to set up the serial, and I'll show you how to do that in a moment. So with no more ado, let's go and look at some sample code, okay, and get started. So what I've got is the standard code that we normally have, okay, and I'll just go over to it here. It's code 100, and essentially what I'm going to do is I'm just going to delete some stuff. I'm going to put that back in a minute and save it, okay. So same as normal, got the chip at the top, and option explicit says we have to define our variables. So if I just compile it up now, it will probably complain. It will probably do it okay. It just won't work because we have not set up the PPS. We have to set up the PPS. So how do we go about setting up the PPS? Well, we're going to use something that we've seen before. Okay, I'm going to show my desktop. We're going to use PIC-info. Why are we going to use PIC-info? Because it's going to help us find PPSTOOL. Because if I click on that icon there, a thing called PPSTOOL comes up. PPSTOOL has inputs here. It's pre-selected the chip because I took it from PIC-info. It has inputs at the top, and it has outputs that we're going to be using, and it has a diagram of the chip. I'm going to take TX1. I take TX1 and I'm going to connect it to port C6. So I just select it, then add it. It's created a little configuration for my chip. It's got my chip name and it's got a subroutine. It's got everything all set up for you. So all you've got to do is copy that into the cut and paste and put it into your program. And it's set up PPS exactly as we need it. It says it's on port 6. That says port 6 is an out. And it's set up something called RC6 PPS to a specific hexadecimal number. Now, what's important? You cannot copy the PPS from one chip to another chip. It's very specific. You take another chip, it might be hexadecimal 10, it might not be. Do it explicitly every time and it will work fine. Okay. I've updated this little diagram we've been looking at here. I've added in the TX1 on port C6 there, and that seems to work well. And then all I've done is I've added in some commands, some string commands. So serial string commands like carriage return line feed, HSERPRINT, put a string on the serial terminal, HSERPRINT the chip name, at the chip frequency, another string, a carriage return line feed, and then down here I've added in which direction the LEDs are flashing in, and the current value of the delay. So how do I set that up? Because I've set up PPS, I've set up the string, I just need to tell it the baud rate. And in here you can see I've got a new define, and it's called USART baud rate. And if you're using a second USART, you can do a similar methodology. And the baud rate I'm going to select is 9,600 because that's what I do them all at. And then I have to add in, just because I want to ensure that the chip leaves this USART TX blocking, and it just makes sure that each byte leaves the buffer and it doesn't get overwritten. It's quite a safe way of doing it. So what have we done? PPS, two defines. Now we can use HSERPRINT, and it's all derivatives. And if I press F1, you can see it all working. So I'm going to bring up my terminal software. My terminal software is now on the screen. Have I got two copies of it running? Probably have. I'll bring up the one that's already running. It's here. Let me just bring that up. No, that's not what I want to see. I want to see it on the terminal. There we go. Great. So I've connected my software. I'm going to connect it to COM port 8, and that is when I plug the TTL, this little TTL USB thing in, that's the number it's been given. I've selected 9.6, and I'm just going to disconnect it, connect it, that's fine. There we go, it's running. And this is now connected in logically. If I program it, program the microcontroller with our new program, you'll see some traffic. I'll just clear that down. And look, it says it's got some numbers. Now, what is it doing? It's showing us that the direction of travel is R, so I'll just disconnect, is R, meaning it's going to the right, and the current value of the potentiometer is 48. I'll reconnect it. You're going to have to trust me on this because I'm going to go over to the lab and I'm going to rotate the potentiometer, and I'm going to do this behind your backs because I can't get the camera to do everything at the same time. So here we go. I'm going to rotate the potentiometer. At 96 is its one value. The other range is 25. And we could look at the source code, and I think we'll figure out why that is later. Okay. If I push the button, the LEDs change direction, and so does the letter L. It's still a 96. Look at that. I've got a range of 96 to 25, and that's because in the code, remember, we randomly set up some, and that's exactly what the scale is in here. Look, the scale is 25 to 100, so I could put that up to 200, my scale. I'll just reprogram that, and we'll I'll bring up the terminal, let's clear that down. It's reprogramming it now. And now I've got a greater range. 192, that's because the voltage is slightly out, that's not a problem. And the LEDs are working. If I push the button, like that. So, it's extremely simple to use serial communications with Great Cow BASIC. Let's have a look at the syntax we saw. We saw how we set up the PPS using PPSTOOL, and you can get at that from your installation. And essentially that sets up the USART for you. You put two constants in, one is baud rate and transmit blocking is always useful, and then you just use the commands of HSERPRINT, coach turn line feeds or send it strings, etc, etc. So it's extremely useful. It's extremely useful. I use an awful lot, I can't deny it, but that's what I wanted to show you, how simple it is to use serial with Great Cow BASIC. So, serial's done. Connect it. All I do is USB connector in, connect two wires up, start transmitting. It's just really very simple. So tomorrow we're going to put that aside, and then we're going to be looking at timer overflows and using an 8-bit timer and a 16-bit timer to flash the LEDs. So, done. Enjoy.